which is good, or maybe you're sort of halfway through it, that's good. Let's stop there then for 3G1. We can sort of leave that for homework, and let's look at the next skill in 3G2. Now we've got two questions here. We've got question 1 and question 2, and this is important because question 1 is going to be something that will pop up in the test. All right. Question 2 is not a skill we're going to assess in this test because it is harder and it does require some knowledge of the next unit. Nonetheless, we are going to go through it to begin to get some exposure to it. Okay, so question 2, not absolutely imperative for this unit. Question 1 really is. We need to have this skill down packed. So, the only extension here is that we're talking about circles in expanded form. And so that means exactly what it sounds like. We're going to expand the equation of the circle. And I've got written up here the both perfect square rules. And it should be my assumption that you've had exposure to this before. Definitely your orientation to year 11 mathematics at the end of last year, all of you have seen this. So we're going to recap it and we're going to apply it in the equation of circles today. So firstly, if we have a plus b in brackets squared, this is what it expands to. A squared plus 2 times a times b plus b squared. And similarly, if we have a take b, it's the same, except we have a negative there. Okay? So, we've got here a circle with a radius of 3 and a center. X is 2, y is minus 4. We can write the equation of that. That's what I've done. That's what we learnt in 3G.1. In 3G.2, we're going to expand it. So let's just consider the x take 2 squared term first. We're going to use the perfect square rule to expand it. Now, of course, one thing you could do is x take 2 squared is the same as x take 2 times x take 2. So you could FOIL, right, and collect like terms and simplify it. That's going to take much longer. When we can use these efficient rules, we should. So we're going to look at that and we're going to say, which one of these does it resemble? It resembles the second one because of the negative in there. All right? And so if we're lining them up, we can see the x term corresponds with a and the b term corresponds with 2. So that means when I expand it, I'm going to put x where the a's are and I'm going to put 2 where the b's are. And that's all I'm doing for the expansion for it. So it's going to be, I'm going to put x where the a is. You're going to have x squared, take away 2x. All right, I've put x where the a is, there and there. And now I'm going to put 2 where the b is, so there and there. All right, so hopefully you can see we've got x squared, take away 2 times x times 2 plus 2 squared. All right. X corresponds with A, 2 corresponds with B, and I'm just substituting it into the formula. Okay, let's leave that as it is now, and let's expand the y. So now I'm going to look at the y plus 4 squared, and I'm going here, and which one does it correspond to? It corresponds to the top one because it's a positive, so it's going to be the same, except with a positive. So again, if we compare this to the top, y corresponds with A and 4 corresponds with B. So I'm going to substitute y where A is, y squared plus 2y, and I'm going to substitute 4 where the B is, there and there. All right. So substitute y where the A, 4 where the B. All right, now, when we're performing mathematics, we're communicating it as we progress down, right? So I've expanded this, but all of it is still equal to 9, all right? It's an equation. This is equal to this expansion. The y plus 4 squared is equal to that expansion, and it's all equal to 9 when we add it together. So we're maintaining that equality. Okay, in the next step, we're going to simplify it, all right? And so that means we're going to have x squared take away, here I've got 2 times x times 2. 2 times x times 2, 4x. That's the simplest way for us to write that. And then at the end there we have plus 2 squared. The simplest way to write that is going to be plus 4. All right, moving along, we're going to have y squared. We have plus 2 times y times 4. 2y times 4 is going to be 8y. And we have plus 16. All right, maintaining the equality, it's equal to 9. Then we're going to look along here and we're going to go, what terms can we collect? I can't add x squared to y squared because they're not like terms. I can't add x squared to minus 4x because they're not like terms. They don't have the same power. But I can collect the numbers, okay? I've got here positive 4 and positive 16. I can add them together. And so I'm going to do that. So what we'll have is we'll have x squared take 4x. We're going to have plus y squared plus 8y. And when I have 4 plus 16, that gives me plus 20. Okay, so we're communicating it as we move down. All right, this is still equal to this statement. The only difference is I added 4 and 16. And when we have it in expanded form, we have all of the numbers on the left-hand side and we have 0 on the right-hand side. So I've got one more thing to do, which is subtract this radius squared from both sides. I'm going to take away 9 and take away 9. All right, so that's going to give us x squared take 4x plus y squared plus 8y. Now 20 take away 9 is positive 11. And that's equal to 9 take away 9 is 0. All right, we've got it in fully expanded form. All right, so that'd be full marks there for the expansion. So this is a skill we need to know how to do. Mason?
Does it matter the order of the numbers written in the final?
Technically no, but it's helpful to write it like this, particularly for me as a marker. So you've got your x squared terms first, your y squared terms next, and then the number. So order does not technically matter, no, but it just looks nicer like that, I reckon. Okay, so that skill, we are going to assess you on that. If you're a bit worried about it, let me know, because I will just break it down into practicing this skill, because in the question here, I'm assuming you know how to do this, all right? So if you're a bit confused, that means let me know and we'll go back and we'll just focus on that, and that'll help you follow it through. Okay, so that's the first skill. That one is accessible. The next skill is going to be a little bit of a stretch, and this one is not going to be, we're not going to assess it this unit because we're going to learn more of these skills in the next unit, but nonetheless, it's a good time to develop some exposure to it. So we're doing the opposite, all right? We're starting with a circle that is fully expanded, and we want to put it back into factorized form because this tells us the center and the radius. Here, I mean, you can put that in your calculator, you can put it in Desmos and it'll graph a circle, but we've got no idea what it looks like. We don't know where its center is located, we don't know what its radius is, so we're going to determine that. We're going to unpack that by completing the square, by doing the opposite. So I've got this statement here. My very first step is that I'm just going to put a few spaces in, all right? I'm going to put x squared plus 8x. I'm going to leave a space there. I'm going to have y squared take 6y, and I'll leave a space there. And I'm going to add 25 to both sides. All right, so I've moved 25 over, and I've just left a few spaces so that I can add some things in. Now, this term here is what we call a quadratic term. It's a quadratic because the leading power is 2. Its highest degree is 2. So quadratics take this form, ax squared plus bx plus c. What we need to do here is complete the square. To complete the square, we need to add b on 2 squared and subtract b on 2 squared. So if we're looking along here, my value of a is 1. My value of b is always the coefficient of the x term. That means the number in front of the x term. What is the number in front of the x term? 8. So I'm going to add 8 divided by 2 squared. But we can't just randomly add 8 divided by 2 squared. All right, because we've added it, we also need to subtract it. So that's how we would complete the square. Or we can think about it like this. We can do anything we want to an equation as long as we do it to both sides to maintain balance. So in fact, rather than adding it to both sides, to complete square plus b on 2 to both sides. Let's do it that way, rather than adding it and subtracting it. I've added 8 on 2 squared to the right side, the left side, sorry. And so therefore, I'm going to add it to the right side as well, plus 8 on 2 squared. All right, so we're completing that square. Now we're going to complete this square as well. And so we're looking along there and I'm going, what is the coefficient? So here we have another quadratic and I'm saying, what's the coefficient of the y term? It is -6. So we're going to add b on 2 squared. We're going to add -6 on top of 2 squared. We're adding it to the left side. So therefore, we need to add it to the right side as well. I might just clear a bit of space because it's looking a bit confusing. So we've added -6 on 2 squared to the left. Let's do it to the right. Okay, so let's recap what we've done in this one step. Okay, we've moved from the first statement to the second one. The first thing I did was move the 25 over, and I've left a bit of space here so that I can add the coefficient of x divided by 2 squared to both sides. We're maintaining equality. We're doing the same with y. I'm adding the coefficient of y divided by 2 squared to both sides. All right. This is always going to be the process for these kind of problems. So it's like, why on earth am I doing it at first? But I'm going to demonstrate to you why right now. So let's reflect on then what we have here. One way that we could possibly express it is we've got x squared plus 2 times x times 4. 2 times x times 4 is the same as 8x. All right. 8 divided by 2 simplifies to 4. So we've got here plus 4 squared. All right, so that can be expressed like this. All right, similarly, let's move on to this one. We've got y squared. Take 2 times y times 3. 2 times y times 3 gives you the 6y. There's the negative out the front. And then 6 divided by 2 is 3. And it is negative, but because it's squared, it's going to be positive. It doesn't matter that the negative's there. So we can express it like this, that's fine. And then on the other side, all right, so all I've done, maintaining equality. On the other side, we've got 25 plus 4 squared plus 3 squared. All right, 8 divided by 2 is 4 squared. 6 divided by 2 is 3 squared. The negative has no effect because we're squaring it. Okay, so here's the reason why we've added b on 2 squared. We have made this a perfect square. Look at this and look at this. They have the same form, right? We have a squared, we have x squared. We have 2 times a, we have 2 times x. We have b is 4. All right, so hopefully you can see a corresponds with x, b corresponds with 4. So because we've expressed it like that, it's fully expanded, we can go the other way. If we have a statement that looks like this, we can simplify it to look like that. All right, if it's expressed like this, we can simplify it to that. And so this whole thing simplifies to x plus 4 squared. All right, I said a corresponds with x, b corresponds with 4. All right, a corresponds, and then they simplify to that one, x plus 4 squared. Okay, move on to the next one then. We're looking at this completed square. Again, this is a completed square. The difference is we have a negative there, right? And so the negative, we're using this form. We've got y corresponds with a, 3 corresponds with b. We can go straight to y take 3 squared. And like you can check to see if it's true, if you're skeptical. If you expand that, this is exactly what you're going to get, okay? That's exactly what you're going to get. Similarly with this one. And what's it equal to? On the other side, we have 25 plus 16 plus 9. I'll just leave it like that for now. 25 plus 16 plus 9. So what's that? 4150. Okay, so this is the form of a circle that we are familiar with. Its center, the center of this circle is x is minus 4, y is positive 3. That's the center of the circle. And the radius squared is 50, right? The radius squared is 50. So therefore the radius of this circle is the square root of 50. Okay, so I'll just talk about the textbook then. So if that's 3G.2, all right, so question 1 and 2 are this skill. That's why I put those ones on your checklist. Question 3 is this skill. All right, so that's going to be sort of extension. Encourage you to have a go at it. It's not something we're going to assess, but question 1 and 2 we definitely will. So if you're a bit worried about what was going on there, that's okay. Like it's going to be something that we do approach a bit more in the next unit. Very good. All right, so I would like you to, even if you haven't finished G1, move on to 3G2, question 1.